The key about taking a multiple choice test has always been the same. If you have things that are in the answer that we've never said in polite company, then it has to be wrong, right? So that means that we've never said the phrase data manipulation, data monitoring, or database conversion, right? Not once have you heard those mentioned out of my mind and mouth until just now. So the correct answer is delta. And probably the same thing is going to happen on 2. Well, 2 is going to be different because as we, anybody got a good answer for 2?
We have A.
A? If you have A, mark it wrong.
Then it's C.
B, mark B wrong. No, C is correct. So it's a process where we draw inferences about the entire population based on information in a small sample.
But in the book it says it's based on characteristics of the population. So that's why I was so confused. I thought they were both on the right.
No, the small sample is what we're doing our inferences on. See. Okay, now don't be confused by the facts over there. I told you not to open your book. Could be worse. Don't know how, but it could be. 3. Anybody got a good answer for 3? B as in boy. D as in dog is correct. The height of a building measured in feet. Oh, feet data. That's good. I like that. I'm not sure I would have spelled it that way. I would have spelled it differently probably. Okay, everybody, no one's complaining about 3? All right. Moving on to 4. Oh, bummer. Exhibit 1-2. That means I have to go back and get more stuff.
That's a sign.
I know. Well, that was good. That was just so Marvy. I just can't imagine. One more last time before I ask if anybody's got an answer to it yet. I'm losing it up here. Huh? You could just tell me the right answer and then everybody would be happy?
No, you could just read it from there.
No, my trifocals don't focus like that. Okay. We have 1,600 voters. 57 approve the president is doing his job. This is an example of, let's see, population, no. A sample, no. Descriptive, no. It looks like a C. Think it's C? See what the key thinks. Well, you're going to mark them right.
Well, I know that. I said, I'm not going to do well on your test. Because I thought I knew some of the answers. But apparently I don't.
Well, I guess it's not C then. What did you get? You like B? All right, I'll go with B then. Does that help anybody out?
No, I had C.
You had C? All right. B. Now we have to read it and figure out what it's trying to say. We have a sample of that, voters, that many approve of the president. This approval is an example of, yeah, I'd go with either one. I don't see anything wrong with either of those answers. That'd probably be okay. All right, last one. Yeah, we don't want to be confused by anything here. All right, now, And since when did you want to do well on a test? I don't understand. When did that start? In 3rd grade or something? No, really. Anyway, I guess that might be a goal. In many universities, students evaluate their professors by means of answering a questionnaire. Assume a questionnaire has 45 students, okay? The students are asked the following: blah, 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 blah. Refer to 1-4. How many elements are there in the above data?
11.
Six.
There's 6.
I put D, 45 students.
How many elements? 45, you're right. So the 45 students are the elements. Exactly right. If it were, what's the other word if it's not elements? I forget.
Categories, maybe?
Yeah, if it's categories, and then they 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
See,
But the elements, 45 students. Okay, at the end of the class, after we do the Chapter 2 quiz, pass in your quizzes with your name and your grade on top, so that we can proceed. Okay, back to, we only have a mere, I don't know how many, 30. Only have a mere 30 slides before we can start doing homework. All right, well, so this is Chapter 2, Part B. We're going to have stem and leaf displays. Stem and leaf displays. All right, so there's the stem, there's the leaf, there's another leaf, there's another leaf, there's another stem, here's another stem, there's another leaf. All right, well, that must be what they're talking about. Cross tabulation and a scattered diagram. Okay, that'd be, yeah, I got something like that. Got points scattered on it. Okay, that seems reasonable. I can handle that. Let's go to the full page.
Are we on Chapter 2?
Already?
Page 49.
Wow. We're already in Chapter 2? I thought I had mine open to Chapter 3. I better move back. There, now I'm better. Okay. Yeah, I think we are. Yeah. In fact, this is the second day on Chapter 2 already. Better check the syllabus. Maybe I'm ahead. Maybe I threw the syllabus away. Yeah, I never printed one out. Okay, well, can't look at syllabus. I'm pretty sure we're in Chapter 2. We're going to do something with the data so we can quickly summarize it and use it for something. And I'm going to use a stem and leaf display. Oh, here we go. Oh, darn. I thought sure we'd see that. Rank, order, shape of the distribution, similar to a histogram. First digits of each data item are arranged on a vertical column left, and we have a stem. Isn't that nice? Let's see one. Can we see one? Okay, 50 tune-ups. There's that. We've seen that data before. Thank you very much, author. And now, oh, there we go. So here's my stem, and there's my leaf. It looks like a horizontal bar chart to me. Does that look like a horizontal bar chart? Yeah, it looks sort of like a horizontal bar chart. Okay. I sort of like the ancestral one myself. But they want me to do a horizontal bar chart and call it stem and leaf. You can stretch to the display vertically so you can have two stems. Wow, a 0 to 4 and a 0 to and a 5 to 10. Let's see that. Okay, there we go. I don't see any difference there, do you? No. Leaf units. A single digit is used to identify each leaf. The leaf unit was 1. So I could have 100, I could have 10, I could have 1, I could have 0.1. The videos together anyway, and it's when I get done, I only have 1. The leaf unit indicates how many there are of the stem. All right. So there's our data. Going to do a stem and leaf showing that data. Stem unit 0.1. Okay. Got it.
So in the
Okay.
book, it's talking about.
So I've got 11.7, 11.0, and I've got a 10.2, and I've got a 9.1 and a 9.4, an 8.6 and an 8.8. I got it figured out already. Yes, what's the question?
Nothing.
Excellent. Is that clear as mud now? Except how could it possibly help you any? I don't know, except to answer the question if you had to write one, right?
When would you ever use this?
I can't imagine anybody.
I would never want to use
Let's
this.
say I was a member of the House of, I was a member of the Senate, U.S. Senate, and I wanted to explain the national debt in a way that no one could understand it. I would probably go immediately to this particular representation, so that no one would understand what I was doing.
Yeah, like that doesn't make any sense.
So you have to be maybe a third grade teacher would teach it to her third grade class, because those
They would
kids.
have fun with it.
That's right. They'd have fun with. That's right. They'd have fun with it, and they wouldn't have to write big numbers, and they could use their crayons. Yeah. Okay. Well, now that we've established that, I'll be sure to put as many of these questions on any test I can, if I can find them anyway. If you have data such as the following. Okay. So there's my data, and we're going to use the unit of the leaf is 10. Okay. Excellent. Thank you. So there's 16s, 17s, 18s, and 19s. So there should be a 16,
Well,
8,
yeah.
1682. There we go, 1682. Because we're not, the units are irrelevant, because we're only going to go to 10s. So the unit position's irrelevant. So we got 1682. We have a 17.1. We have a 17.9. We have an 18.0, an 18.3, a 19.1, and I'm going to go back. I might go back. Previous. Now one could ask the ridiculous question. Guess we got to go back previous again. Why am I not rounding up? You know, why isn't this rounded up to 1810 and I have a 1 there instead of a 0? Why isn't it rounded up to 1840 and I have a 4 there instead of a 3? And the only answer to the question is, that's not how they told you to do it. So we're ignoring the data we're ignoring the fact that a normal person would round that up, and a normal person would round that up, and a normal person, because we're not normal people anymore, we're statisticians. We're trying to make the data so we don't understand it. Really? Maybe a cross tabulation. Okay, so we've done one variable at a time. Now we're going to do 2 variables. Okay, so we're going to do I'm going to go between, have a variable of number of hours I work versus my hourly pay. The guys that get paid the most should be there the most, right? Probably not, but could be. So anyway, we're going to do something like that. Scatter diagrams using 2 variables. Cross tabulation, 2 variables. Both variables are quantitative or qualitative. One variable is one, the other variable is the other. Well, isn't that lovely? What a waste of a transparency. The left and top margins define the classes of the 2 variables. Okay. Finger Lake homes. The number of Finger Lake homes sold. All right. So there's our price range, home style. Okay, do we get numbers? Totals. Well, that took a long time. All right, so we have a quantitative there, we have a quantitative there, we have some category variable. All right. Maybe I could do that given some data. Yeah, my wife sits at home and has found the home improvement channel and is now thinking that I should be doing these home improvements in the house. And every time they have a house, it's $450,000 and it's all trashed out. Obviously, we shouldn't be watching this show. Insight. We're going to gain insight from this cross test. All right. So the greatest number of homes are less than 200,000. Now that was really some insight. You price your homes cheaply, you sell a lot of them. Only three are A-frame style, which is left over from the 50s when we had ski chateaus. Did I go the right way? Oh, frequency of the distribution. All right. What do we got? Frequency distribution of the home style. All right. Sounds like another thing to miss on some tests. Tabulation. Oh, we could do it in a percentage. So now we've gone and changed the total number of homes to a percentage number. And why would we care about the 100th of a percent? You know, it would seem to me if I was going to have percentages, I'd just have like two numbers. Forget the decimal thingy. Row totals are actually 101 due to rounding. All right, well, thank you very much. Okay, column percentages. So now we're coming down this way, come up with percentages going that way. Maybe we can do that. Maybe we'll have to do that later. Uh-oh, Simpson paradox. Is that the guy that runs a nuclear power plant? Might be. Yeah, I think it is. Data in two or more cross-tabulations are often aggregate to produce a summary cross-tabulation. Right. We must be careful in drawing conclusions about the relationship between two variables in a aggregate cross-tabulation. Maybe they'll show us why. In some cases, the conclusions based upon an aggregate cross-tabulation can be completely reversed if you look at the unaggregated data and reverse the conclusion based on the aggregate, and unaggregated data is called the Simpson paradox, which is probably exactly why he runs a nuclear power plant. That's probably the case. Scatter diagram. A graphic representation between two quantitative variables. Okay. Trend line. Let's see a scattered diagram. Here it comes. Okay. Now, if that line was going the other way, what would it be? Okay, so if it went that way, like that, what would it be of?
Negative.
It would be of the size of stars versus their age, how long they last. But a graph going that way, I don't know of any. Well, that could be Ohm's law, I suppose. It's going that way. E is equal to IR type of thing. Anyway, positive relationships. Oh, a negative. Oh, here we go. Negative relationship. There we go. Now I got a negative relationship. As I have more money in the bank, I get less interest. No apparent relationship. All right. Oh, very good. So, let's do a haul on this for a moment.
Kind of find the average. The line goes through the averages.
Yeah. So, in World War II, and I have this 500-pound bomb. How close did it get to the target? I'm dropping a 500-pound bomb from my airplane. Here's my airplane up here. How close did it get to the target? Okay, now, have you ever watched the History Channel?
They dropped a lot of 500-pound bombs.
Yeah. So when you're watching the History Channel and bombs are being dropped, what are they hitting? Ever notice what they're hitting?
The surrounding area.
They're hitting the orchards and the farmland. Did you ever notice that? No, you probably don't watch the History Channel and wait for them to drop bombs during World War II. Anyway, the average bomb in World War II fell within a half mile, 1/2 mile of the target. Okay, so if I'm trying to get the elementary school, the K through 8 school here, I would have missed it, and I would have got the hospital instead. Okay, the only reason we ever hit our target in World War II is because we sent out 100 planes at a time and dropped thousands of bombs, and a couple of them happened to get close enough to the target to make some damage. So that was just one of those things. We did a little bit better in the Vietnam War. We got it down to a 1/4 mile in the Vietnam War. So we still had to drop lots and lots of them to get to where we wanted to be. And then in the Gulf War, the whole nature of warfare changed, as we had smart bombs and they could blow up on the target. And now you could fly a P-52 over the area with 25 500-pound bombs on board, and each one of them were going to hit within feet of what it was supposed to. And that changed the whole nature of warfare. But that's sort of like a scatter chart. So you're there, and you're dropping your bombs, and they all land over here. What are you going to do? You're going to change your sight a little bit so that you can maybe have them all drop there, even though you're. So now you're going to aim here in order to drop them there. That's what you'd use a scatter chart for, to see if I need to make some correction or not. No apparent relationship. It's not going up, it's not going down. Sort of like the stock market. Not going up, not going down, staying about the same. Panthers football team? Anybody at the basketball game on Saturday? No? The cheerleaders put on their performance. They're taking to nationals this weekend. Good luck. Last year we came in 3rd place. I don't think so this year. They better start getting a little bit better. We won. We had a 20-point lead. We blew it. We only won by 14. You know, I'd be upset if I was a coach if I blew a 20-point lead. Winning by 14 is okay, but you ought to. Win. You ought to, and the team ought to just keep on going. We're 19-0. We're undefeated. Can you imagine that? How can that be? Iowa Western, undefeated. Undefeated football, undefeated basketball, undefeated. What was the other thing? Was it girls softball? We came in national champs this year. Maybe it was. Anyway, so. Is interested in investigating the relationship between the interceptions and the points scored. Well, that should be an easy thing. You have a few interceptions and the points scored. Okay, interceptions, points scored. There we go. I'm looking at them. All right. Does it do me any good? Can I draw any conclusions? Well, the more interceptions, the more points scored, I guess. And I do a scatter chart, and voila. We should speed this up some. Looks like a lot of work. Do I get a line? No line? Okay. Looks like it is a positive curve. As I have more interceptions, I have more points scored. The funniest thing happened when I was in South Berwick, Maine. I was there for 4 years doing things in the Navy shipyard. The school was a small school. Maybe 150 people a year would graduate. And my daughter was in 9th grade. The team was Class D. They went undefeated. They never kicked an extra point. They never kicked a field goal. They didn't have either one. And they never punted on 4th down. If they got the 4th down, and go for it. They weren't scored against normally. The first team only played the first half, and then came back in only if the other team got down to the 15-yard line, and then they'd go in to shut them down. The next year, we're Class C, and we haven't grown any. We're the same size, Class C. We're undefeated. We didn't kick a field goal. We didn't kick an extra point. We didn't punt the ball. We went for it on 4th down, but normally there wasn't a 4th down. We'd run right, we'd run left, we'd go up the middle. Normally we got a 1st down when we ran right. We didn't have to run left. And they passed the ball once that year, that whole season. It was 4th and 45 because of penalties. And they went for it on 4th and 45, and the quarterback threw a pass and caught it, and we made a 1st down. All right, next year we're Class B, and we haven't changed the school yet. We just changed our class, and we're playing other guys. Undefeated, same thing happened. And the 4th year we were Class A. We're playing the big guys now, and we go undefeated 4 years in a row. When we look back at the coach of the football team's been there for 20 years. He's lost 20 games already in 20 years, and most of those were early. And he is a gas station attendant. That's his real job. He just coaches the team on the side. So how do you do that? And of the team players, none of them went on to 4-year schools to play football. Now, how did that happen? Well, what happened is that the community 20 years ago decided we're going to do football. We're not going to do soccer. We're not going to do softball. We're not going to do all these other things. So starting in kindergarten, we play football. Well, by the time they get to 9th grade, these itty-bitty guys, it only takes one of them to tackle a great big guy. And these itty-bitty guys, when they have the ball running right, left, and in the middle, these 5'6", 120-pounders, it take 2 or 3 guys to tackle them. Well, it's just a matter of I know the fundamentals and I'm executing the fundamentals. Now, when they get to the 4-year schools, they can't be on the team. They don't have the weight. They don't have the body mass. They don't have the height. They don't have anything. The quarterback for those 4 years was the high school principal's son. The whole 4 years we went undefeated. Totally amazing. Anyway, so insight gained. If you want to win at football, start in kindergarten. Scatter diagrams indicate a positive relationship, or it might indicate a negative relationship or no relationship. There is my line. I knew I was going to get a line on something. So this is my interceptions versus points scored in a line. All right, now we're going to have tubular graphical methods. I think we've seen this guy before, right? Quantitative, qualitative, tabular. Oh, not tubular, tabular. Frequency distribution, bar charts, pie charts. Are we done? Do I get more? I do. All right, so I have a whole lot of different ways to represent the data, and I'm sure that I'll do that. And now I'm done. All right, so we're done with the transparencies for chapter 2. So now the issue is, what homework problems are we supposed to do?
We got up to 17.
All right, so we got up to
23, 29, 35, 41, 47, 53.
Ike. Okay, so the issue is, what's the next one?
Page 20, or
60.
23.
Oh, no.
23?
Yep.
All right, so we're going to do number 23 next. And it's probably in multiple parts, and it'll take at least a half hour, right?
Nope.
No?
No. Stem and leaf diagram.
Construct a stem and leaf diagram of the following data. Okay. I'm going to put a line here. I'm going to put a line there. And it looks like I've got, I'll start at 6. Okay, so I'll go 6, 7, 8, 9, 10, 11. And then I got an 11, 3. And I've got a 9, 6. And I've got a 10, 4. I got a 7, 5. Got an 8, 3. Got a 10, 5. 10, 0. 9, 3. 8, 1. 7, 7. 7, 5. 8, 4. 6, 3. And 8, 8. Am I done? Pretty much. I could add more lines, right? I could do something like that. Well, that was very edifying there. So on the next test, you want at least 3 or 4 of those, right?
I can do those.
Yeah, you can do that one. Okay, so you can do that one. All right. Next one.
Number 29.
29.
Page 60.
These had better get done hard very quickly, otherwise we're going to be so bored. Let's see. I better get my calculator out in case it has to charge its battery. Never can tell. I might have to use it. All right. The following data is 30 observations involving 2 quantitative variables x and y. The categories for x are A, B, and C, and y are 1 and 2. Develop a cross tabulation for the data with x on the row variable and y on the common. Well, you're going to tell me how to do it. All right, so I'm going to have x on the row, y on the common. All right, so y. So I could have a 1, or I could have a 2. Or does it mean the other way? I could have a 1 and I could have a 2. Yeah. Probably means that y goes on the y-axis and x goes on the x-axis. You think that's what it's trying to tell us? X. A, B, C?
Y.
A, B, C.
Yes, I'm not giving this version.
With
Doesn't
x,
the Y go left to right and the X go up and down?
with x as the row variable and y as, yeah, I think so. I think I was right the first time. All right, so I'm going to have A, B, C, 1, 2.
Very good.
Okay, good enough? Okay, so the issue is how many A1s do I have? 1, 2, 3, 4, 5, 5. How many B ones do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many C ones do I have? 2. 2? All right, how many A2s do I have? 0. How many B2s? 2.
Yeah.
2? C2s? 10? Okay, so 10, 13, 18, 20, 30 total, and I have 30 observations and they're all accounted for. Compute the row percentages, compute the column percentages. What is the relationship between, if any, between X and Y? All right, so we're gonna, do I have enough room? Okay, I'm gonna do row percentage. Row percentage. Okay, I've got 18. So 5 divided by 18. We'll call it 28%. 11 divided by 18. 61%. 2 divided by 18. 11%. 6, 7, 8, 9, 100%. Okay, 0%. 2 divided by 12. Call it 17%. 10 divided by 12. 83%. Okay, so that's column percentage. Bummer. And I said I was doing row percentage. So column percentage is in black. Row percentage will be in green. Row percentage. All right, 100%. 0%. 11 divided by 13. 85%. 15%. And 2 divided by 12, 17%, 83%. What is the relationship, if any, between X and Y?
The A values are always 1, B and C are sometimes, or B is sometimes 1, and C is sometimes 2.
That sounds like none, right? I mean, can we say that if X goes up, Y goes down? Can we say if Y goes up, X goes down? Can we say they don't go at all? I think the answer is there is none. I don't see any. What is the relationship, if any? Okay, no, I still don't see any relationship. So the one guy does this, and the two guy does that, right? This guy has a hump. That guy just has a straight line. So yeah, I think that there's no relation. Now, on the test, the author's been kind enough to give me the key. Isn't that nice of him? But I'm going to take the test too. So that means the right answer is whatever the author says it is and whatever my answer is. So if I, for some reason, disagree with the author, then either one of those would be fine. That makes sense? Yeah. Because who made up the key for the author? Some super brilliant person or some grad student that just got there and got assigned to do it? Yeah, exactly. So keys are something that are made up by the grad student. No one ever checks them. Not that we're any more brilliant than they are. Okay, next problem.
35.
30. Oh, good. 35 is short. I'm looking at the 45 mutual funds on page 63 and thinking about, oh, I hope I don't have to deal with that.
Yeah, you did.
Oh, I do have to deal with that? Oh, bummer.
Unless you want to skip this one.
Who did that?
That one's
Oh, refer to that table.
Mm.
Prepare a cross-tabulation of the data on mutual funds in rows and expense ratios in columns using classes 0.25 blah 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 for expense ratio percentages. Okay, so I'm going to make a cross tabulation and mutual fund types on rows. Okay, fund type. All right, so we have D, E, I, E, F, I, we only have 4? You only have 3? D, E, I, E, F, I. Well, I guess we need more room then. D, E, I, E, F, I. I suppose someplace in the book it tells us what those mean. And expense ratios. 0.25 to 0.49. Am I going to have enough room? 0.5, 0.74. Well, gee. .75 to 9. One, 1.24, 1.25, up. Okay, so I'm almost ready. All right. So, and we're doing it, expense ratio. Okay, I see it. So DE gets 1 here. IE gets 1 there. FI gets one there. DE gets one here. DE gets one there. IE, DE, 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 FI, DE, 1, DE, FI, IE, DE, FI, DE, FI, DE, 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 IE, DE, FI, DE, IE, DE, DE, FI, DE, IE, DE, IE, DE, FI, DE, IE. Now how can that be? One over there for FI. Another one over here for FI. How come we have two of them out of our class? Huh?
It didn't ask for that. It didn't ask for those numbers.
Yeah, no kidding.
Well, we don't
There's
count,
three. There's another one. Three of them outside.
and we don't count those.
And then a DE there. Okay, so now we did that. So we have 1, 4, 3, 1, 3, 5, 2, 0, 0, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 2, 1. Okay, so everyone's accounted for. Prepare a percent frequency distribution of the expense ratio. Prepare a frequency distribution of the expense ratio. Okay. So we'll go with the same data again. Let's see how we're going to do that. Okay. We'll go and do a and get everything a little higher. You're going to have a hard time doing this with your crayon set. Edit, paste. Okay, so there's all of our data. And we'll erase the blue. Now, what are we going to do with the outliers, I wonder? We should probably keep them. Is probably what we're going to do. And we're going to use green for our percent. There are 45 mutual funds. Okay, so if I was on, 1 divided by 45. 2%. 0%. 4 divided by 45. 9%. 3 divided by 45. 7%. 2%. 3. Oh, we already did that. 7%. 5 divided by 45. That's good. 11%. 10 divided by 45. 22%. 7 divided by 45. 16. 2 divided by 45. Did we already do that one? 4%. 7%. 4%. 2%. 0%. 0%. Alright, so now we have a percent frequency distribution of the ratio. What conclusion can you draw about fund type and expense ratio? Okay, so the conclusion we would draw, DE is best of all. That'd be a reasonable conclusion to draw. Or maybe not. Maybe IE is better. 3, 4, 5, 6, 7, 10, 17, 20, 26. 7, 26, 4 times as much. No, it looks like the IE guy is better, doesn't it? He has less numbers, but if he had the same numbers as that guy did, he'd have better numbers, wouldn't he? So we're going to go with IE. IE is best of all. Oh, we have. Yeah. So I look at this and I say 17, 20, I have 26 stocks in that group. 3, 4, 5, 6, 7, 8 stocks in that group. Which means I have 26 divided by 8, 3 1/4 times as much. 3 1/4. 3 1/4 times 3 is how much? Oh, it's not 10. 3 1/4 times 2 is greater than 5. 3 1/4 times 3 is better than 3. 3 1/4 times 2, 6 1/2. Well, I don't know that I'd come to that conclusion. Alright, DE and IE are about the same. IF is bad. Is that good? Bad? IF is bad. I don't know if it's bad or not, but it doesn't look very good, does it? No, it doesn't look very good. Okay. Okay, that's an excellent conclusion. Single syllable words for everything. Perfect. Okay, next problem. We done?
41.
41. 41. Dividend yield is the annual dividend paid by a company expressed in percentage of the stock price. The dividend yield for Stock Jones, blah, 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 blah. Okay, I see it. Construct a frequency distribution and a percent frequency distribution. Okay, so to have a frequency distribution, we have to set up some categories. Okay, so the bottom of the heap looks like 0. So it looks like we go from 0, and the top of the heap is 9.2. 9.2. So what do you say we have 5 categories? That'd be okay? 5.2 divided by 5. All right, so we'll go 0 to 2. 2.1 to 4. 4.1 to 6. 6.1 to 8. And 8.1 to 10. All right, so those are the categories we have, and we want to know frequency distribution and percent distribution. Okay, so change the blue. 1 there, 1 there, 1 here, 1 there, 1 there, 1 here, 1 there, 1 there, down there, over here, there, boom, there, boom, there, there, there. So how do I know that 5 ranges is the right thing to do? I don't. I don't know what the author wanted. If he wanted 6 or 4 or 5 or 10, he didn't say, right? So we picked 5. It must be right. If you were to pick one range, then that would be silliness, right? So that wouldn't tell you much, but this tells you a little bit. So my frequency distribution, I'll go back to that color. 1, 2, 3, 4, 5, 6, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 2, 1. And how many are there? 16, 22, 24, 25, 30. Okay, so 6. Now we're going to go to frequency distribution, percentage. We're going to go to percentage frequency distribution. 6 divided by 30. 20%. 16 divided by 30. 53%. 5 divided by 30. 17%. 2 divided by 30. 6.7%. I'm not sure I want to do that. If I want to call everybody else a whole percent, I should call that guy a whole percent too, right? 7%. 1 divided by 30. 3%. 3, 10, 20, 30, 40, 50, 100%. So 100% everybody is accounted for. I think we're done. Construct a histogram. Okay. Clearly I want to use Excel, right? Do I? Yeah, I probably want to use Excel. But I have to be able to see my data as I'm putting it in. So okay, I can't do both. Okay, so 0 to 2. How come that's not a 2? 2.1 to 4. 4.16. 6.1. 8. 8.1. 10. Right? Six, 16, 5, 2, 1. And where's the view guy? View. There we go. 200%. Much better. All right, so we'll go and do that. And where's my chart? Insert columns. Yeah, that looks okay. Okay. View 100%. That's better. All right. I'm not a histogram yet, though, am I? So I have to do something about not being a histogram. All right, so I'm over here trying to solve my not being a histogram. So I'll go to those shapes. Well, I was talking to one of my math friends yesterday, or Friday at lunch, and telling him the difference between a bar graph and a histogram, and he laughed at me. I figured he would. Typical math guy, you know. So he immediately went and looked it up on the internet to see if I was right. All right, so we want that color. That color. Green. Iowa Western blue. I don't know if that's Iowa Western blue or not. And red. There we go. Good enough? Construct. Comment on the shape of the distribution. It is, if I could spell screwed, how do you spell screwed? Screwed? Whatever the word is. S-C-R-E-W-E-D. Is there an L in it? Left, that way. It's moved left. So I commented on it. What do the tabular and graphical summaries tell us about the dividend yields among the Dow Jones Industrial Averages companies? How about that? See, this is C, this is D. They are low. How's that? We'd like 10% interest on our money. What company has the highest yield? That was the 9.2 guy, right? General Electric. So Echo would be General Electric. Hmm. If the stock for this company currently sells at $20 per share and you have 500 shares, what would your purchase be? What would your dividend be for the year? How much dividend income would the investment generate for a year? Okay. So, this means we have to do some math stuff, right? GE is Delta. Okay, so the dividend yield is defined as dividend divided by the stock price times 100%. Okay, so if I have 9.2 would be my dividend divided by $20 times 100%. Okay, so that'd be 0.092 times $20 times the 500 shares I have. 0.92. 0.092 times 20. Well, put fat fingering keys up here. $920 would be my dividend on 500 shares. You like that? Is that okay? Too much math? Too much multiplying and dividing at the same time? I divide by 100, so I have to move the decimal point over 2 places. When I put that on the other side of the equation, I then multiply by 20, and then so that's dividend per share. I got to multiply by 500 shares, $920. Now, could I do that if they wouldn't have put in the problem that the percentage price of the stock is dividend divided by stock price times 100? So if they didn't tell me that, I probably couldn't do the problem. But they did tell me, so I can. Okay, next.
$47.
47. Oh, good. Another A and B problem. Refer to the data set for high and low temperatures in 20 cities in exercise 46. That must mean the other page, right? Okay, I see it. This is very interesting. It says web file, right? Let's see what I got. Because I downloaded all the web files. Web files. Excel files. Chapter 2. We're in Chapter 2? Oh. Now, how does this help me? City temperatures. Oh, isn't that nice? So I have all the city temperatures high and low. Okay. Well, let's hope I remember that I have those next time I see it. Now, how come I can't turn on enable editing? Well, I can't enable. Okay, well, I can't enable the editing. Okay, so what? All right, 47. So I got the web file. Let's see what, develop a scatter diagram to show the relationship between the two variables, high and low. High and low. Okay. If I go in and do, maybe if I did this, if I did that, but I don't have, I don't have those tools. Okay, well, okay, so I'm gonna go take the data, I copy and paste it into my other spreadsheet. Yes, I can. All right, so I got it copied into my spreadsheet, and I'm going to go insert a scatter chart. Which one do you like? First one? Yes. What do you think? Awesome. Yes, totally awesome. Okay, so we did that.
Do you want us to draw that?
Of course you'll have to draw that.
What
Yeah.
is the bottom?
What? Yeah, of course you have to draw that.
It's a second to draw.
What is the Y?
Oh, you want to, huh?
What is the Y?
Temperature, high and
What's
low.
the X? High and low?
Yeah, high and low. Yeah, that's how it did it. Yeah, scatter chart between two things would be high on one side, low on the other side.
Well, if that was the case, then
Yeah, there
why
you
isn't there a 36 or a 43 or a 50 on the low?
Why isn't there a 50 on the low? What's that right there? There's a 50 on the low. There's another 50 on the
That's
low.
high.
Series, no, these guys are low. Oh, I don't know.
Because the high looks like it's in the X axis and the low looks like it's in the Y column.
Okay, so Albuquerque goes from 39, so that's Albuquerque right there. Albuquerque going from there to there. That's Atlanta going between there and there. That's Baltimore going there to
Okay.
there.
So I get that the X axis is the
Yeah.
temperature. What's the Y axis?
The x-axis
That's
is
the
the
Y.
city. No, that's the x. This is the city.
Okay,
Oh, in line, the first
Yeah,
five.
and this is the temperature.
the first 5.
Yeah, because there's 20, if you count, there's 20 cities there. Notice how it doesn't go past
Oh
40.
yeah.
Instead
How
of listing
come?
every city.
Listing every. Oh, got you. Thank you.
They didn't do it all? No, there's only 20 cities.
No, he's good.
I'm good.
Oh, you're good? Everything's fine now?
Well, we gotta draw it though.
Yeah.
Fine. I'm gonna put it in my other thing so I can do something with it. All right, while you're summarizing the scatter chart, let's see if I can make it bigger.
I would have done that.
I don't believe it. Triangles. Oh, it's not triangles though. I really don't understand why Excel couldn't put the city names in there. I mean, they could have done that if they wanted to. Comment on the relationship between the high and the low temperature. Okay. So the people with the highest high also have the highest low. There, how's that? Is that good? I'll write that down once we get done doing something with this thing. So for the test, I should get the laptop cart with a printer for every computer, right? No, you just want to do it freehand. Okay.
Okay.
We'll turn the capture thing back on. Okay, next problem.
53.
5, 3. Is 5, 3 the last problem? It might be. Refer to table 216. 216. Okay. Data for sample 500 companies. All right, well, let's go see if we can find the web data. I suppose it'd be a good idea for me to put the web data on the web page.
Be nice.
That'd be okay. I mean, that would take maybe my graduate assistant will do it for me. Oh, I remember. I don't have a graduate assistant. Excel. Alright, so data for 500 companies. Fortune. Think it's that one? Yes, it is. Isn't that nice? Isn't that lovely? Having all that nice data sitting there. Okay, so what am I supposed to do with it? Prepare a scatter diagram showing the relationship between the two variables profit and shareholder equity. Profit and shareholder equity. Okay, so we're going to do the same thing again. We're going to,
And selecting it that way, aren't you gonna put the,
We don't want market value.
yeah, I do. Because I can't do it in that spreadsheet. I don't have control of the things I need control over. So I have to go move it to where I can have control of something. And now that I have control of it, I can do a delete of the market value, which I don't want. Delete. Oh, yes. There, does that solve all your problems?
Yep,
Every single one of them, except the,
until we have to start drawing the second.
except, well, there's only 50 of them, right?
There's a lot of numbers.
Only 50.
Only 50.
I don't even have enough room on it.
Yeah, only 50. All right. All right, so I got it. I got the data. Insert. Scatter. All right, do we want the first one again, or do you want one of the ones with the lines in them?
Sure. Mine's good.
One with the lines?
Why not?
Oh, no.
No?
This is gonna be really tough.
No, we don't want that one?
No.
All right. All right, so we'll try it again, and we'll do a different one. All right, so we'll insert, scatter. We'll try that one. Oh, isn't that lovely? That is just so Marvy.
Can we put Saul on teacher's spreadsheet?
I don't see why not. Don't you have a spreadsheet on your cell phone you can do this on?
No.
Oh, bummer.
I can go home and do it.
Yeah, what a bummer. Prepare a scattered diagram showing the relationship between profit and stock market equity. Yep, that's what it is. Yeah, that is definitely a graph of those two things.
Okay. Relationship.
53.
Or table 216, right?
What happened to my thingy? There's that one. What happened to my chart? Come this didn't get over there. Boom. Oh yeah, there we go. There, does that make it better? According to the television, bigger is better, right? Oh, that lost focus though. My eyes can't focus on it anymore. So that would be what a scatter chart of 50 items looks like. Isn't that just wonderful? Just think if we had to go and prorate it or something and do something silly like that. For homework? Yeah. Yeah. I go and print it out and just add it.
Okay.
Yeah, I'd do something intelligent. Figure out something intelligent to do, whatever it is. Okay, so now we got a comment on any relationship between the two variables.
Yeah.
I like none. What do you think? Anybody else thought none?
The higher the
There's no same relationship too, no.
I mean, it's nice that they're in alphabetical order. Yeah, I don't, the higher the market cap, the more the profit, I suppose. I don't see anything other than none, no. See. Well, you'd expect the higher, the more equity there is, there'd be more, you'd have more profit, right? So we'd probably go with that. Same thing we went with last time. Higher. Is that higher? Higher equity implies more profit. Okay. So we're done with chapter 2.
That was the last one for chapter two.
That's pretty disgusting. All right. So the way I see it, we don't start chapter 3 until next week, right? Is that a truism? Yeah, this week. So we don't start chapter 3, so we can't start it early. And we can't go home an hour and a half early. But, well, when we get done doing the chapter 2 quiz and reviewing it, and then I get done putting everything on the web that I need to put on the web, it's going to be after 8 o'clock anyway, and the other teacher's going to have to kick me out of the room, right? Okay, so we'll do a Control-Alt-F. Oh, there we go. Okay, so number 1 is D, number of things. Now, why is it? Now I've done it. Oh, there it is. Put it over here. Number 2. Anybody got an answer for number 2? The cumulative frequency distribution. The last class will always have a cumulative frequency equal to
I had C.
the total number of elements in the set. So C is correct. Now what's the difference between C and B?
I think it's like a time divider.
Yeah. So I could have 5 things, right? But I could have 10 of them and maybe at 200% for everything. I could. So 100% would be meaningless in this particular case. All right. Is that 2 C's in a row? No, not yet. Okay. This is a falls into the category of we only talked about one thing. It must be it, right? All right. So it has to be C because we only talked about symptoms, parallel. What's Simpson's rule? Anybody know? Simpson's rule is something you use in calculus to find the area under the curve before you learn how to integrate. So it's the thing you learn before integration so that now you can integrate and find the area of the curve. And but I don't recall talking about an aggregated cross tabulation or a wrong cross tabulation. Maybe we talked about aggregated one, but we definitely didn't talk about wrong one. Okay. Lots of words. 800 schools, cross tabulation with the majors, blah, blah, business engineering. All there is total. Refer to what percentage of the students does not plan to go to graduate school?
65.
65%?
Uh-huh.
Oh, right there. Graduate school. Yes. So that'd be 52 over 80. And you're saying times 100. You're saying that that's That's 65. 52, my calculator's off, so I can't tell. Divided by 80. Yeah, you're absolutely right. 65% C. All right, lucky guess. All right, now we want to construct a frequency distribution. Okay, so I'm going to have low and I'm going to have high, or D and L. 1, 2, 3, 4, 5, 6, 7, 8. 8 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of those. Oh, that can't be right.
No, it should be 9 and 11.
Yeah.
9 and 11. So I got 9 and 11. Then I want a relative frequency done of the 9 and 11. So I'd go 9 divided by 20, and I'd have 11 divided by 20 times 100 is what I'd put in my calculator. And I wouldn't write anything like that on my paper. I just put the answer on my paper, right? 9 divided by 20. So I'd have 45%. No, it wouldn't be a percentage though. It'd just be 0.45. Relative frequency distribution. So that's not a percentage thing. 0.65. Then I gotta do a bar chart and a pie chart. Okay, so I'm gonna do a bar chart. Low, D, 9, 11, and then I'm gonna do a pie chart.
Yeah,
Hmm?
I have a question for you. How'd you get 65.65? 11 times 20 times, or divided by 20 times 100 came out to 0.55 on my calculator.
It did?
Yep.
I got it because I looked at the 52 divided by 80 and wrote it down again from the last problem. That's how I did it. Any other question?
What?
Oh.
Yeah, question.
Huh?
Don't you take 11 divided by 20?
Yeah. But when I looked at my calculator with my trifocals, I looked at the wrong
Oh.
spot.
Okay.
Okay.
There, is that better?
Yeah, that's fine.
Yeah, you're good.
Yeah, I looked at the 0.65, the answer I got from problem number 4, and put it there. Yeah, that was totally brilliant, right? My explanation, anyway.
There you go.
Yeah.
Makes sense.
Yeah. See, when you make it to 62 and you're wearing trifocals, you can come up with all kinds of good excuses for stuff. You know, before then, you sort of until you get your first set of trifocals, you have no excuse for much. But as soon as you get your first set of trifocals, and oh, I can't see a damn thing. Okay, well, now I got to make a pie chart. Okay, you can't go straight across, right? Can't do that. So I got to have a little bit more of one than I do the other way. So this has to be my L, and that has to be my D. And then we'd probably put a 0.45 there and a 0.55 here, maybe. I don't know. We really don't need to have numbers in a pie chart. Okay, with that, the instructions are put your name on your quiz and your grade on your quiz and pass it in, and then I will commence doing other things. I guess I should take attendance next. Wouldn't that be good? Oh, wait a minute. There's 9 of you here, everyone's here, so I guess I don't have to do that.
I was saying, I think next Thursday's she's gonna test that, if I remember right.
Yeah.
Oh, we gotta look in the, gotta go to the website and find that out? No, we don't, yeah, we're not here Monday. Monday is Martin Luther King Day.
So it'll be the
So
following
it'll be the
Monday.
following Monday.
Yeah.
Yeah.
You want both of the same
Thursday
thing?
next
Oh,
week.
yeah, I'll figure it out.
All right.
Yeah.
Tuesday. Next Monday is the 21st. We don't have to be here. But you can show up.
You can come.
Everybody. Deal?
There, Batman.
If we could try. Come on, now.
Hey, you gotta try it.